Hi, welcome to SolidCam. In this video we are going to talk about generic 5-axis machining. Generic 5-axis machining is the main module inside SolidCam's 5-axis, and using generic 5-axis machining the user can machine any kind of part inside SolidCam. There are absolutely no restrictions in the type of tool or type of part or type of tool axis that could be used, and any part, any shape, any size can be machined using the generic 5-axis toolpath. So in this video we are going to see few parts, and one of the part is right in front of you. It's a closed impeller, and this kind of parts can also be done using the generic 5-axis. So what I have here is a tube kind of a geometry, and this geometry can easily be done using generic 5-axis, where the user has to define the tool axis geometry, and the tool will follow the tool axis geometry while machining the part. Complete collision checking is possible. So if I edit the tool path and show you the parameters, so we are using morph between two boundary curves. There are several options: parallel cuts, parallel to curve, parallel to surface, perpendicular to curve, morph between two boundary curves, morph between two boundary surfaces or adjacent surfaces. And then we have projection using user-defined radial, spiral, and offset. So we have used morph between two curves here, and if I look at the drive surface, so those are the drive surfaces, the cyan colored ones are the drive surfaces, and I have the upper curve, which is my first curve, and the lower curve out here, which is my second curve. So the pattern happens between them. We are using a lollipop tool in this case, and in the tool axis control it's tilted through curve, and if I show the curve, this is the curve through which the tool axis is going to pass through while it machines it. In the gout check we have got complete collision controls. We can set up to 4 different collision groups and define different reactions to the collisions. So if I run the simulation of this is how it's going to look like. That's how it's going to machine, and it keeps rolling on the surface as it enters the part. So parts like this can be done using generic 5-axis. So this side, and also machining from this side. All this can be done using the generic 5-axis engine. Let me show you more parts. This is a turbine blade, and a turbine blade can be completely machined using the generic 5-axis functions. For example, we could use the new generation tools that are currently very popular in the market, like barrel tools or lens form tools. In this case I'm using a lens form tool. Okay, I've used a lens form tool here with a large radius at the bottom, and we have finished this part using morph between two adjacent surface. So if I have to show you the simulation, this is how it looks like. So we use the bottom of the surface, and the advantage of going with a lens form tool is that you could give a bigger step over and yet achieve the same amount of scallop that you would get with a 16 dia ball nose using a very short or small step over. The same part can also be done using a bullnose tool. So we can have a bullnose tool, and in this case we can use the bullnose, the front of the bullnose, to cut this part. So if you look at the contact of the bullnose, you'll see that it's actually not using the center of the area, but it's using the front. The front of the area is being used, and all these things can be controlled in generic 5-axis. It's a very powerful functionality where you can control almost every aspect of the tool path. Now you could also see that we can do the fillet machining also using generic. For example, this is how the tool path looks like. So if I run the simulation, you can see that we're using a taper ball nose here. Using the taper ball nose, we are completely able to finish the fillet. So again, like I said, it's a very powerful function. We can also finish the side faces here. So if you look at this one, we can also machine using Sim 5X. So generic 5-axis machining is a very, very powerful functionality to machine any kind of part in 4 or 5 axis. Let's look at another part. This is a portion of blisk, and here we are using the generic 5-axis to machine the blades or finish the blades. And in this case, we are using, if you look at the tool path, we are using a oval form tool, again a pretty popular tool nowadays. We're using an oval form tool, and I have kept the contact at 40% of the barrel profile, and again we have used morph between two curves, and this is how the part is machined. This is completely done using the generic 5-axis functionality. Now the limitation of these new generation tool is that you can't get a longer length, so this complete part cannot be finished using the barrel tools or oval form tools. So they actually stop at a certain point. So if you look at the tool path, the tool path stops at a certain point. Beyond this, it's difficult for the tool to go because of the limitation of the length. Whatever remains can then be performed or then be machined again using generic, but using a different tool. So you can see that the generic machining is capable of handling not only regular standard tools but also the new generation tools like barrel tools, oval form tools, or lens form tools. Let's look at another part, which is another blisk itself. So here I have a complete blisk, and to machine this blisk, you actually do not need any special techniques. You can machine this entire blisk using the generic 5-axis itself, including roughing as well as finishing. For example, the roughing here is done with a bullnose tool. So we have used what we call as parallel to surface functionality, and based on the parallel to surface functionality, we have done the roughing of this entire blisk. And then we've used morph between two curves to do the machining using an oval form tool. Here, since the height of the blade is not much, you can actually go all the way down, but again there's a limitation that the oval form tool doesn't machine all the way down, so there will be some areas that will be remaining which can be finished using the taper ball nose at the bottom. So the areas that cannot be finished with oval form tool can be finished using taper ball nose. This again is an example that such parts can be easily done using the generic machining in 5-axis or 4-axis. Thank you very much for watching this video.